Now, let's talk about the Tisch TE1000 Puff High Volume Air Sampler, the TE5170 TSP High Volume Air Sampler, and the TE6070 PM10 High Volume Air Sampler. My name is Alex Pickle and I am our Service Operations Manager here at our Pittsburgh warehouse location. I have a degree in environmental science through Robert Morris University. I've also been working here for 4 years. I also come with experience working with the Tisch models that we are talking about today. Let's talk about the purpose of high volume air samplers. They are used for area monitoring and clearance sampling. They are also used for the assessment of aerosol contaminants such as dust, gases, or other toxic vapors. They're commonly used to sample particulates, lead, pesticides, and semi-volatile organic compounds. Now let's talk about the maintenance to expect while using your Tisches in the field. Brush changes every 500 hours of use should be expected. Motor changes every 1,500 hours of use. After 2 brush changes, a new motor should be used. Ensure that all gaskets are in good shape and seal properly. This will impact your flow rate. Remove foreign objects such as bugs or leaves from the filter screen during sample changes. Ensuring the Dixon chart reader's needle ink cartridge is recording on the chart. Mounting to secure your unit for sampling should also be considered, as well as maintaining sample filter stock provided by your lab. The first unit we're going to talk about here today is the TE1000 Puff High Volume Air Sampler. Now let's talk about the Tisch TE1000 Puff applications. The Puff High Volume Air Sampler collects airborne particulates and vapor contaminants. These samples are typically used to collect volatile organic compounds and airborne pesticides. The system incorporates a dual sampling module to collect volatile organic compounds, airborne pesticides, and PFAS in ambient air. So how does the TE1000 Puff sampler work? This sampler operates between 125 to 250 liters per minute and uses a manual motor speed controller. The flow is pulled through the critical orifice with either a brush or brushless style vacuum blower motor assembly, which is used to control and calculate the ambient flow rate. These instruments are housed in an aluminum shelter that houses the timer, magnehelic gauge, vacuum motor, elapsed time indicator, flow venturi, and dual sampling module. So let's get a little hands-on with the Puff TE1000 Tisch High Volume Air Sampler. First, let's talk about the sample orifice. This is going to be the model in which you use for the TE1000 Puff sampler. This is also where you will be housing your sample, similar to this. Simply place this inside of here, make sure your gaskets are sealed, twist it shut. You can also apply a filter on the top of the orifice. Simply place on the top of the unit, on the intake like so, and you're ready to sample. You also have your motor assembly, as well as your mechanical timer, as well as your magnehelic gauge, which will help you monitor the flow rate. You also have an elapsed time indicator to monitor your brush and motor swaps, as well as your total run time, as well as your motor speed adjuster situated here. Next, let's talk about the TE5170 TSP High Volume Air Sampler. So let's discuss the TE5170 TSP applications. A total suspended particulate sampler, or TSP High Volume Air Sampler, is used for the collection of total suspended particulate in the ambient air with no preference to size selection. The TSP High Volume Air Sampler collects particulate at a flow rate between 39 to 60 cubic feet per minute over a constant sampling period. In most cases, a Dixon chart reading of 40 cubic feet per minute and above for the overall sampling period is what determines if the sample is valid or not. These also can be used to determine the concentration of total suspended particulates or can be used to determine the identity of the particulates. So how does the TE5170 TSP high volume air sampler work? The vacuum motor pulls ambient air onto an 8x10 glass fiber filter. The TSP air particulate samplers do not use a particle separator, which results in the collection of all ambient particulates. The glass fiber filters are weighed pre and post sample, and the weight is used to determine the total suspended particulate matter. The TSP unit can function with a volumetric flow controller or a mass flow controller. Each will function with the use of a flow sensor located beneath the filter. They also can operate on both a brush and brushless motor system. So let's weigh in on the mass flow controller versus volumetric flow controller option. For the mass flow controller, the motor speed can be adjusted using a hot wire anemometer probe to control the flow rate. The user can adjust the flow rate from 39 to 60 CFM, and the controller will ensure it stays within that range. Versus the volumetric flow controller, which uses a critical orifice with a predetermined orifice hole diameter to control the flow rate. The orifice is drilled and calibrated to let only the predetermined flow rate pass through the filter. This will allow for a constant flow rate of 40 CFM. And finally, let's talk about the TE6070 PM10 high volume air sampler. So let's discuss the TE6070 PM10 applications. A PM10 high volume air sampler is a Federal Reference Method or FRM instrument designed to collect ambient particulate matter with an aerodynamic diameter of 10 microns or less. This sampler uses a size-selective inlet to separate out the particulate matter that is larger than 10 micron, ensuring that only concentrations of PM10 are deposited onto the sample filter. These samplers typically operate with a flow rate between 36 to 60 CFM during a 24-hour sampling period. So how does the TE6070 PM10 sampler work? The PM10 high volume air sampler collects particulates at the flow rate between 36 to 60 CFM. As the particulates travel through the size-selective inlet, the large particulates are trapped inside of the inlet as the smaller PM10 particulates continue to travel through the PM10 inlet and are collected onto the 8x10 quartz filter paper. The quartz filter is weighed previously to sampling and then after sampling to determine the mass of the particulates that are smaller than 10 microns, similar to that of how the TSP sampler works. The flow rate on this instrument is controlled by either a mass flow controller or a volumetric flow controller. So let's get a little hands-on with the TE6070 PM10 high volume air sampler. As you can see, it's a little bit bulkier than the PUF and TSP sampler. However, this is because of the PM10 inlet. And as you can see, this top part is our inlet assembly. From here, you can see where the particle separation happens with the PM10 being separated from the TSP. From there, we have our filter placement, where we have this design to house our 8x10 filter paper. This is where your samples will be swapped in and out. From there, we have our motor assembly, as well as our Dixon chart reader. Popping this lid open, we have our Dixon chart and our ink cartridge. It's important to make sure that the ink cartridge is full and reading correctly on the Dixon chart, as well as making sure that your Dixon chart is orientated correctly for the night and day and time. From there, we then have our mass flow controller located here near the bottom of the unit. Lastly, let's talk about our calibration options for our Tisch units. For the PUF high volume air sampler, we have two options available: the TE5040 slack tube calibrator and the TE-HVC-P X calibrator, or digital calibrator. For the PM10 and TSP high volume air sampler, we also have two options: the TE5028 slack tube calibrator, or the TE-HVC-V X calibrator, or digital calibrator. Field Environmental Instruments provides Tisch rentals and expertise. We also provide customers with motors, brushes, and parts, and we would love to help you in your next event where you need high-volume air sampling equipment. Well, we finally hit the finish line, and thank you for making the pit stop to learn more about the Tisch high-volume air sampling options. We appreciate your time and enjoy the rest of the HasWhopper.